moving waste is at position 50 meters at time 4 seconds. Can you determine the car's velocity? If so, do it. The definition of velocity is the rate of change of position. So if you want to know the velocity, you need to know how fast or at what rate this position is changing. So if you know, you need to know your initial position, the final position, and the time. Okay, so we know that the position is 50 meters at time 4 seconds, but we don't know if it was starting at position 0, if it started at position 125.2. We don't know where it started. All we know is that it is at the final position of 50 meters when the time is 4 seconds, but we don't even know if the elapsed time is 4 seconds. Did it start moving when time was 0 or when time was 2? So the problem, though, the biggest problem is that we don't know the initial position. So no, we can't find the position, not without the starting position. Can a car traveling at 30 meters per second have the same acceleration as a bicycle rider traveling at 2 meters per second? Explain. So acceleration is the rate at which velocity is changing. So if your velocity is 30 and with an acceleration of 0 meters per second squared, that means constant speed. Well, if the bicycle is going 2 meters per second, could it have an acceleration of 0 meters per second? Sure, that just means it's also at constant speed. So the answer is yes, but it could also have an acceleration of 1 meter per second squared, because that would mean that the car would then be going, starting at 30, then we'll be going 31, 32, 33, etc., right, meters per second over time. Where the bicycle rider would start at 2, then go to 3, then go to 4, then go to 5, right? That's how its velocity would change. So yes, absolutely, they can have the same acceleration. Can an object travel a great distance but have 0 displacement? Sure. Anytime you take a road trip and you travel, you can go a really far position, right? You can change your position a lot and travel a great distance. But then if you end up back where you started, you're going to have 0 displacement. So let's define these terms. Distance is the amount of ground covered in a trip, where displacement is the total change in position. So a long trip, such as one from New Jersey to Florida, is 2,000 miles approximately round trip. That's distance. But if you end up back at home, it's 0 displacement. A toy car is sitting on the hallway floor. A student gives it a push. Describe the motion of the car in words from beginning to end. So let's use terminology. So the car is at rest with an initial speed of 0 at position 0 meters at time equals 0 seconds. And then you give it a push. So the car increases speed in a straight line, moving to a new position. And then you can maybe go on and say, if you know this, the friction from the floor causes the car to slow down, accelerating to a velocity of 0. Okay, so that gives you, you're using some vocabulary, you use the word speed, you're starting at rest, there's a type of motion, you've got the position, time, so you're using the terminology. A student drops a bouncy ball from shoulder height. Describe the motion of the ball in words from beginning to end. So you could say the ball starts at rest above 0 position. When released, it is in free fall because the only force acting on it is gravity. Acceleration due to gravity causes the speed to increase downward until reaching the ground. How does the time up compare to the time down for a ball that's thrown straight up and falls back into the hand that threw it? So when you start here and it goes to max height and then comes back down, remember we talked about the symmetry of a freely falling object. So the time up is equal to the time down in free fall. This is because of the symmetrical trajectory. Right? At the top of its path, what's the acceleration of an object that's been thrown straight up? Well, if you're in a, so this is a freely falling object. Therefore, acceleration equals little g, which is 9.8 meters per second squared, which is rounded up to 10. A bullet initially at rest reaches a speed of 600 meters per second by the time it exits a 0.75 meter long rifle barrel. The student wants to solve for how much time it takes for the bullet to exit the rifle, and your job is to figure out what these things are. So which value is time? So that's what we're looking for. This is the unknown. Which value is distance? Here it is. That's how long it is. So that's how far it's traveling. Note the units is meters. The initial velocity, it's initially at rest. The final velocity is given. Remember, you got to put units on everything. And the acceleration is we don't know. It's not given and it's not our unknown. And that's what we're going to do. A tortoise crawls steadily for 1,000 meters in 1.5 hours. How fast is it moving? We know it's 1.5 hours. The distance is 1,000 meters. The average velocity is the unknown that we're looking for. Acceleration is 0 because it's moving steadily, so it's an implied constant speed, and when something moves at constant speed, acceleration is 0. A ball is launched along the floor with an initial speed of 15 meters per second. If it slows at a rate of 2 meters per second squared, how far will it travel before it comes to a stop? So the time is not given and not asked for. The distance is what we're looking for. This is the unknown. The initial velocity is 15 meters per second. It's coming to a stop. This implies final velocity is 0. And acceleration is right here. I know that because of the units, 2 meters per second squared. So we're trying to identify our values that we're interested in, right? These are the things that we have definitions for, and we're trying to find them in the word problem.